So I can see we do not have that many attendees today, but I'm sure more will join us in the next few minutes. So maybe I can just start by asking those of you who are already, how are you doing with your coursework? I'll be asking you every day. You won't escape. Anybody needs, help? Have you got any questions you think you can share with all of us?
Yes, I'd like to ask a question.
Yes, please.
So I was doing a bit of reading how if the demand went under a certain level.
Okay.
And then there was something else about voltages that I couldn't really understand, that it was troublesome to switch voltages, and I think it was something at a low demand, there were high voltages and they couldn't invert the voltages.
Okay.
I don't really understand what voltages have to do with the grid and how that plays into distributing.
Okay, you might need a different source. So that's welcome to the magical world of electrical engineering for electrical grids. It's a whole other discipline altogether. I mean, people do a couple of degrees and several years of work experience to be able to be competent in these things. So that's perfectly fine if you don't understand it. I have to say I'm not an expert in electrical management of grids, even though I've worked on grids many times, and most of my consulting customers are electrical grids. But there are still things, when it comes to the actual electrical engineering that I don't completely understand. So for the purpose of your work, probably the only thing you might need to know is that there is a constant balancing effort on the grid. So that is the balancing between demand and supply. And indeed, there are times where you might be having more supply than demand. Yeah, because I think this is the situation you refer to, isn't it? That there is more supply than demand.
Yes.
Probably, yeah. So that can tip the grid off balance, and it can create, for example, an electrical surge, a voltage surge, or it can create a frequency surge. So typically your frequency will be something like, depending on where you are, but it'll probably be around 50 hertz in most of electrical grids. I don't remember what's the situation in Western Australia. And you will have a voltage of, say, 230 volts on at a household level. Now, normally that would mean that if your supply is higher than your demand, you could be experiencing a higher voltage, because essentially what's happening is that there is too much energy on the grid which is not used for anything. So that energy has to go somewhere. So it has to manifest itself. So typically, in very early stage monitoring of such systems, typically you will have frequency controls. So you will be trying to read the frequency of the system to see if there's any early warnings, of the frequency going 50.3, 50.4 hertz or something like that. And a lot of the a lot of the demand response systems that we have, so a lot of the automations we have, that instead of managing supply, they manage demand, actually operate on that premise. So they look at the frequency and they can act immediately, either by reducing demand or increasing demand, if that is if there is an issue with the frequency, and that is seen as the kind of the best fast response way to balance the grid. But there's also voltage. To be honest, when the voltage starts coming up and you have like rapid surges of voltage, then it's probably, I don't want to say too late, but probably you start already damaging appliances at this point. It's very likely. So then you need more emergency measures that can take, can increase demand quite significantly or switch off power plants quite rapidly. But again, you need to be able to understand, how bad is the situation and how many power plants you need to switch off. So it's a very, what's the word I'm looking for? It's a very delicate act. It's not very easy, and it's something which, like, imagine 20 years ago, if you had problems like that, you would literally shut down the whole grid. So there was not much you could do other than shut down everything and start it back from the beginning in the way that you wanted to start. So you started again in a more balanced way. Today we have much more clever power electronics that can detect these things before they become too bad, and they can start taking a more intelligent approach in switching off and on certain consumptions and switching on and off certain power stations. It's not perfect though. It's not perfect, and there are lots of issues around topography and where the power station is and where the consumption is and what kind of cables are in between them, and if you can consume that energy on the cables and so on and so forth. Like I said, it's a very delicate act, all of that. My opinion is, don't worry too much about it. The bit that you need to know is it's difficult to balance a grid overall. And yes, indeed, there is such a thing as having too much supply for the demand that you have. Is the situation you're talking about a situation where, for example, you had, I don't know, too much solar, for example, at a certain time of the day, or too much wind that could not be absorbed by the grid? Is this the kind of situation you had?
Yeah, and I also think that it was too much solar from behind the meter. So houses that installed solar were using their own energy and not using what was on the grid. So the grid was overloaded by the energy that it had bought prior, I think, to meet demand. But that demand didn't happen because the demand was being met by behind the meter solar.
Okay. So this is very interesting. Let me just say here, do you want to say a little bit for the rest of the class, because I'm not sure everybody knows what is behind the meter? What do we mean with that?
If I understood correctly, behind the meter means that it doesn't communicate with the grid, so it can't. It's.
Don't worry. No, just say it how you understand it.
Well, I understood that, as I said, it can't communicate with the grid, like not a two-way communication.
Mm-hmm.
So it can spill onto the grid, but it can't take it back.
Okay, so let's think of it a little bit like that. When we say behind the meter, let's think a little bit of the architecture you have there. So you have electricity coming on cables, at your doorstep, and then entering your house. Yeah. Now, right there, where it enters your house, there is a meter. What that meter does is it measures how much electricity comes into your house, and that's for billing purposes. That is to allow your electric company to give you a bill at the end of the month. And that might be a smart meter, so it can be a meter that communicates with, sends data essentially back to your company, and really, give them already that kind of consumption data and so on. Or it can be an old meter where it doesn't send data back, and somebody has to come to your house and take a look at the meter and see, okay, what have you consumed this month, and then bill you based on that. And they sometimes kind of come every month, or they can come every 2 months or 3 months or once a year or whatever. So that is what the meter is. Yeah, all of us who live in houses normally have one. Now, an important detail here is the meter only assesses the energy that goes in your house. Whatever you do from the meter onwards, so within your property, is not necessarily seen by the meter. So, and traditionally, of course, the only source of electricity that you would have for your house would be coming from outside towards your house, yeah, from the grid to your house. It was a one-way system. Traditionally, it has never been anything different. And your house was basically a consumption center. So you had all the sockets, and you would consume energy. Now, the idea of having solar panels at your roof changes a little bit. All of that. So now you could be having solar panels on your roof, and you could be doing a few things with them. So you could be using that energy directly. So imagine you have your solar panels on your roof, and there is a lot of sunshine, and you produce electricity. That electricity needs to be consumed. So ideally, you will have enough demand inside your house to consume it. And you might have or not have enough demand. That depends. So sometimes your house might be consuming a tiny, tiny amount of energy. Could be only your fridge, or it could be even nothing at times. Maybe a standby device, or a TV set or something like that. So it can be a tiny, tiny amount. At other times, if you have an electrical shower, it could be an enormous amount of energy. It could be 7, 8, 9, sometimes kilowatts of power. Or if you have an electrical oven running together with a shower, or if you have a heat pump, an air conditioner, or whatever, all of these things together, they can increase the load quite rapidly for a house. So there are times where your solar panels, which might be a couple of kilowatts, typically in most houses, or 3 or 4 maybe kilowatts, might be more than enough to supply your house. And there are other times where they can be not enough to supply your house, which is why pretty much all the houses that have solar panels remain connected to the grid. They don't lose that connection. They don't rely on their solar panels 100%. So with a clever setup, it could be the case that if there is good timing of demand and supply in your house, then energy in your house will be consumed from your panels directly. And then when there is a surplus of energy, that energy will go outside to the grid and can be sold to the grid. Or it can also be wasted. That's the other option. So you can also ground it and get rid of it. It's not necessarily a good option, but it can be done. Or you can switch off certain panels and not produce that energy. There are a few ways to do that. Or in other times where you don't have enough energy production from solar panels, you will be importing energy from the grid to use for your, whatever needs you have on your property. So all of these things are possibilities. And of course, each one of them presents interesting challenges on how your electricity supplier should be billing you. So there is something called net metering. Have you seen any reference to net metering?
No, I haven't.
No? Okay. Anybody else in your work, in your coursework? No? Okay, then maybe it's a good idea to tell you. It's not a class about solar energy today, but it doesn't matter. I can tell you all these things now because you're going to need them anyway. So net metering is when your electricity utility, your company, the company that supplies you with energy, allows you to use your meter in a bidirectional way. So essentially, your meter shows an increase in your consumption when electricity flows from the grid to your house, and it goes backwards when there is flow the other way. So when there is flow from your solar panels to the grid. And that is quite a simple way of doing it, relatively speaking. So then you will pay essentially for, you'll have exactly the same tariff for the energy you buy and the energy you sell. Yeah, because nobody knows the difference, basically. It will show at the end of the month, it will show as if you consumed less energy overall. Yeah, so it will, if you have produced some energy, some more energy during the month, then that will show as a decrease in your consumption. But nobody will know exactly how much you produced during that month. You just show that your consumption was lower than it has been in other months when there was no solar at your house. So the idea there is that 1 unit of energy that you produce has exactly the same price as 1 unit of energy that you can buy from the grid. Not all companies are happy with that, by the way. Yeah, because at certain times, your solar power system could be supplying energy that the grid doesn't need. Yeah, so they don't want to incentivize you to do that by giving you too much money for it, too much as in the money that they would otherwise charge you to buy your energy. So it can be quite tricky at certain times. There are other ways to do that, which would be, for example, one way is to not consume any energy at your house and have a second meter that only measures the energy that flows from your house to the grid. And you allow that to happen independently. So it's a totally different meter. And your company then pays you for the amount of energy you sell to them. And they give you a different tariff. So that's a different tariff, a different amount of money for the energy you sell them, and a different tariff for the energy they sell to you. Typically, the energy they buy from you would be at a way lower tariff. So that's an alternative way. So if you see what I mean, there are different ways of understanding how to price and how to incentivize electricity flows in these situations. But the issue is that once lots of houses have solar panels, you do start having, at the distribution level, having suddenly a lot of energy being produced in the grid, and it needs to do something. A lot of that energy can be on rooftops, so you don't necessarily expect it to happen. You don't really know. As a grid planner, as a company that balances the grid, you don't necessarily know what is happening there because you're not measuring that. You have no idea what's going on if that's behind the meter. And if it doesn't have its own meter, for example, you don't know how much energy is going to be produced. So your forecasting modeling is not necessarily that accurate. So there are balancing questions there, which could tip the system a little bit, off the scale and can make suppliers nervous at certain times. That is, an angle to keep in mind. It's not totally unreasonable. So when you hear, grid companies freaking out a little bit about too much solar, in the system, too much residential solar in the system, that is mainly the reason. It messes up with their balancing. And it does other things as well. Yeah? There are also safety concerns. So imagine from a grid company's point of view, imagine that there is a fault in the grid. Yeah, there's a damage, something has happened, an accident. What do they need to do? Normally, they will need to cut the supply in that area. How do they cut the supply? They have to go as back as possible into the grid. So then they cut a certain area, a certain residential area of the grid. For example, here in the UK, most residential areas are grouped in groups of around 250 houses. So when they need to cut down a certain area because there has been a damage on a cable or something like that, then they would normally cut down, in segments of 250 houses. So let's say you cut the energy in that area, in a couple of roads, in a couple of streets. Now, in the old days, you would think that area you have just cut down, so you cut it down essentially so it doesn't get any energy from the transmission network, from the power stations, incoming into that residential area. But what if the houses that are in this area have solar panels? So then the houses themselves produce electricity, and that electricity spills over inside the grid, because it would. Nothing stops it from doing so. If you're not consuming it at your house, it will more likely just end up going into the grid. Now that company, your grid company, has no way to stop that. So when they were previously thinking that they had cut all the energy in that area, and why would they cut it here? Just to be clear, they cut the energy in the area so they can send their engineers to dig, get the cables out, and fix them. So these people need to be sure that they're going to be touching cables and working on cables that don't have electricity, so that's safe to work on. But if there is electricity coming from the other side, so from the houses, these cables will have electricity, will be live wires. So then it becomes way more dangerous, yeah? So that is, again, another area where a grid company could be very concerned about, having solar PV at houses. And there's no easy fix, I can tell you that. There's no very easy way to disconnect that power from the houses. Because you need to be doing this house by house. And you need to have detailed information about which houses have solar power. So it's quite a challenge. It's not necessarily the easiest thing to handle and manage, yeah? So, I don't know, that was a little bit of an insight of how residential energy, with solar, for example, interacts, with the grid. It is not a very easy relationship. It's a very troublesome relationship because our grid was not built for that stuff. Our grid was not built for this type of, bidirectional electricity flow. It was never thought of it in this way. So all the safety mechanisms that would normally exist for this purpose don't exist. That's all new things that have to be installed. So yeah, most mature markets gradually are looking for ways to do as much as possible behind the grid and stop it there. So if you could, for example, have energy storage behind the grid. So whatever electricity your panels produce, you can store it in your panels, or you can charge your car with, or whatever. Ideally, that is what electricity companies want. They don't want anything to do with the energy you produce at your house. So yeah, it's a new world. A lot of adjustment will have to take place in the next decades. So that's that. Any questions on what we've discussed so far? It was a small question, but then, I took off with it. Rebecca, are you a little bit more clear about what's happening in this segment?
Yes, thank you. That was really helpful.
Okay, good. Others on this issue or other issues about your coursework? Nothing? Okay, so one question, because last time I ended up having a few outstanding requests. Are we clear that this time, have I responded to all of you? I think I have, but if I haven't, I need to know. Is there anybody who has emailed me and hasn't had an answer yet, or whatever? No? Okay, so this time I've done it right. Okay, good. So let's go then to today's class. And I should record. Stop recording. Here it is. Okay, so today we'll. Oh my God! It says, and I should record Chinatown. Okay, so I'm looking at my transcript. So sorry, guys. I'll dismiss my transcript because it says weird things and I shouldn't be saying them. So we talked quite a lot last time about the various types of energy generation technologies. So we talked about turbines and we discussed about all sorts of turbines. We talked about internal combustion engines, and we also talked about solar panels, which is where we focused also the first part of our conversation this morning. Well, it's not really morning, but anyway. Now, there is a little exercise I want you to have a go at today. And that is, it's a little bit of group work, and it's mostly to have us thinking a little bit what types of energy technologies can be used for certain types of activities in a day. So let me, so what I need to do, let me share my slides first. Here it is, okay. So I'll share all the slide deck with you so you have all the types of energy we discussed about. But really the activity we're talking about today is, right now, is this one. So your working groups, and you need to think of the UK's demand curve for a typical summer day. I mean, all of that is in the slide deck, so you will have that. And then you need to take a look at that and say, right, okay, what power stations, what kind of technologies could potentially supply that energy? And it's not necessarily that, there's one correct answer. There can be many correct answers here. Um, and many ways to justify your decisions. But what I want you to do is to go through that thinking process of, that not everything fits everywhere. So certain power stations are better working in those hours when demand is peaking, or other power stations might be better at other times of the day, and so on. So I'd want you to just have a go at it and be open-minded and be speculative about it. So don't worry if you feel that, oh my God, I'm not really sure what is the correct answer. Chances are there are, numerous correct answers, and everything depends on how the grid is organized and how the country's supply is organized and so on. So chances are you will be correct with whatever you say, but it will just give us a good opportunity to have this conversation about, what is working where and what do we need to be thinking of before we make such decisions. So what I'll do, maybe first thing is to share this slide deck with you. So if I do, so can you still see my slides, or has it stopped showing them?
Yeah, we can see it.
Yeah, okay, that's good. And then I'm gonna go in our chat, and I'm gonna pop the slides in the chat. Hopefully this will work. No, it didn't like it. Let me try this again. So if I do this once more, because previously it told me that the file already exists, but I don't think I've shared with you these slides. Have I? Have I shared with you before this slide deck, the slides we're having today?
I don't think so, Professor.
No, yeah, exactly. I thought the same, and I haven't. I'm a little bit surprised that it insists that I have. Not least because I cannot see it anywhere. Okay, can you see what I've shared with you right now? It's in the chat. So hopefully it works.
Yes.
I see it.
Yeah. Okay. Okay, so if you open there and you go towards the end, you will see the slide I'm sharing with you that includes the group work, and immediately after it has a couple of curves with electricity demand on a winter day and a summer day and so on. And that's that. Does it work for all of you? Can you all open it? Does anybody have a problem with the slides I've shared? No? Okay. So If that's okay for everyone then, so what I'll do is I'll split you in groups now. Let me see how many groups that let us do. Oh wow, it keeps. Okay. It has kept the old rooms when we've previously done the exercise. So I'll have to remove those rooms and do new rooms, create rooms. So we will do 6 rooms, maybe 5 rooms, create. Oh, here we go. Okay, that takes some time, but it should be ready very soon. Okay, here it is. So, and then
Hello, can you hear me?
Hi, yes, I can hear you.
Okay, nice to meet everyone. I think we have to start to work, no?
I think so. I think so. So
But the others, we are just me and Chiara. I think so.
yes. Okay.
hello. Are
Hello.
you all kind of okay with what you're doing?
Maybe if you can explain.
Sure, sure. So in the slides I've just shared with you in the chat, have you seen them?
Yeah.
Yeah, okay. So if you go towards the end, there's the exercise brief there, and then there is a graph with the 4 curves, out of which you need to be looking at the typical summer day. And what I want you to do is to think, you know, last week we did all of these different technologies, all the different turbines and all the, you know, the solar panels and the internal combustion engine. And I want you to think a little bit, what kind of power stations could be ideal to meet the demand in those different hours of the day. You don't have to do it every hour. You can do, you know, every few hours, you know, say from the morning and the afternoon and the, you know, whatever. Yeah.
So we can choose what we prefer.
Yes, but think of it in terms of the characteristics of all of these power stations. So you remember with all of the power stations, we were saying that some of them can respond very fast. Some others are very slow, or some of them might be very expensive to run, some of them might not, so, you know, things like that. So if you kind of use these things for your justifications, that will be good. Like I said earlier, it doesn't have to be, I mean, don't worry about this being, you know, absolutely correct, because chances are that there are many correct answers. So it's only a little exercise to think about these things, and then we can all get together and discuss, you know, again, and get more familiar really with how we make these assessments.
Okay, understand. Yeah.
Okay, it's a little practice exercise, nothing else than that. Okay. So I'll see you very soon.
Perfect. Thank you.
Thank you. Okay, so during the night, the demand is very low. So what kind of energy could be used during the night?
You prefer to focus on the night?
Yeah, I think that we have to do the whole day, like from the night, the morning, the afternoon, and then.
Yeah, no, we can choose every segment of the day, but we can choose also, yeah, the night or the morning. And
you think that we have to choose like a period of the day, not all day.
Yeah.
Like during the night we use that energy, the morning another type, and the afternoon another. I thought it was like that.
Okay.
I'm not sure.
I understand. And what do you think of the night hours?
Well, let's see. Surely not the solar energy. But let's see. UK. I don't know.
UK.
Maybe a kind of energy that doesn't have to be very fast, because you don't have a high demand.
Okay, so maybe it's easier.
Yeah.
I don't know the maybe the wind power station, but we have to search if they produce enough wind energy to supply the demand.
Yes. About the wind energy, I don't know how much wind there is in the UK.
Me neither.
I don't know what to think. Maybe also, what was that?
If you are just me and you, we can talk in Italian.
Sì, dai.
Comunque ti dico, io già ho fatto l'altra, quella. Tu c'eri al primo lavoro di gruppo?
Sì.
Ok, e però cioè, pure quella volta l'abbiamo fatto solo in 2 e mi scoccia realmente che poi dobbiamo fare un lavoro per 5-6 persone in 2. Cioè io glielo direi anche al prof.
Abbastanza.
Perché siamo anche la prima stanza.
Ero in un gruppo che facevamo un po' tutti.
Secondo me, se vuoi, possiamo parlare altri 5 minuti di questo progetto. Possiamo anche staccare, ricollegarci alla lezione, quella principale, e dirglielo al prof.
Intanto proviamo a buttare giù qualcosa, giusto per non aver niente da dire. Tipo.
Ok, magari possiamo dire che non ci va troppo di presentare, non lo so. oppure torniamo prima e la facciamo solo a lui. Comunque sì, possiamo vedere.
Vediamo.
Ti dicevo, comunque l'orario dobbiamo scegliere uno solo, non tutta la giornata, no?
Io pensavo tutta la giornata, cioè
No,
che
no, solo una infatti avevo capito che tu avevi inteso tutta la giornata. In
ok.
italiano posso spiegarmi meglio e ti dico che
No, ma
sono...
anch'io avevo capito quello che intendevi tu, soltanto che proprio pensavo così.
Ok, perfetto. Il fatto è che io sono a corto di idee riguardante la produzione di energia in Inghilterra, e quindi dovremmo fare delle ricerche perché magari non producono nulla di vento, quindi non...
No, infatti, anch'io non...
Però le ore di notte ci sta perché comunque possiamo giustificare del tipo che ok, non c'è bisogno, ovviamente non possiamo usare l'energia prodotta dai pannelli solari, tranne se non sono in grado di tenerla,
Sì,
però magari possiamo utilizzare un'energia sostenibile che è scarsa, perché appunto essendo la notte o la mattina non
potrebbe
è...
bastare, tipo.
Sì, infatti potrebbe essere una bella idea perché abbiamo questa giustificazione. Possiamo dire, ecco, l'energia del vento, l'energia geotermica è scarsa in Inghilterra, però pensiamo che se fatta bene, se sviluppata bene, possa estinguere le necessità di quelle ore notturne. Quindi
Ah,
ti direi proprio il livello più basso, cioè dall'11:30 fino alle 5:30 è il punto più basso.
sì.
Possiamo dire anche semplicemente, che ne so, da mezzanotte alle 5 o anche dalle 2 alle 5 se vogliamo restringere il campo.
Beh, ma anche tanto alla fine dalle 11:30 fino lì alle 5:30, 6, rimane sempre bassa, quindi secondo me è tutto uguale lì.
La cosa che pensavo io è non so se cioè, se riesce anche una scarsa a mantenere l'elettricità per 6 ore, perché magari sì, il livello è basso di richiesta, però forse non è così basso da permettere all'energia prodotta dalle turbine del vento di
Però
dare... Sì.
considerando che poi se c'è vento, perché bisogna anche vedere quello, però se c'è vento, il vento poi è continuo e continua la produzione durante tutta la notte e cioè,
Ok,
cosa
perfetto.
intendo?
Ci può
Adesso
stare
non
quello,
so
ci
la
può stare quello che
velocità.
intendi tu. Ora, l'unica cosa che dobbiamo pensare è che comunque parla di tutta la domanda dell'Inghilterra. Quindi dobbiamo considerare che la produzione, ad esempio l'energia eolica, non è che deve essere solo di un'area, ma deve essere in grado di produrre quella poca energia per tutta l'Inghilterra. Possiamo andare a cercare.
Quante sono le-
Allora, intanto c'era quello là che aveva visto ieri, Fork Offshore, quell'altra non me la ricordo, c'era quella mappa che faceva vedere i
sì.
venti in tempo reale, non so se ti ricordi.
Secondo me l'ho messa anche tra i preferiti. Vediamo. Windfinder. Windfinder fa vedere i venti.
Ok, Windfinder sì, brava. Io invece sono in quella Fork Offshore che spiega dove sono le installazioni.
Ok.
Allora. E poi possiamo cercare anche velocemente, che tanto non penso sia troppo difficile, su Irina quanto produce l'Inghilterra. Posso cercarlo subito io fra un attimo. Allora.
Beh, c'è un po' di vento offshore nel mare, però dentro no. Però in teoria hanno le stazioni, le power station lì, le wind turbines ce l'hanno
Sì,
offshore.
sì, infatti oltre che ce l'hanno offshore, ce l'hanno anche praticamente in tutta la costa. Cioè io vedo che c'è una base, comunque mi sembra, se riuscissi a zoomare. Vediamo se... Ci sono comunque diverse basi. mm. Quindi i venti come sono? Sono abbastanza?
Sì, sì, lì alla fine c'è tutto un giro di appunto nel mare, non tanto nella terraferma, però ce n'è. Adesso capire la velocità, tipo un po'. eh,
Sì, sì, no, ci sta. Guarda, secondo me ci sono sicuramente l'Inghilterra sta dando peso all'energia prodotta dal vento, quindi comunque potremmo vedere ora, possiamo dare un'occhiata insieme su Irina, appunto, poi non so, c'erano altre piattaforme, ma onestamente per adesso guardavo solo quella, e possiamo vedere quanto produce, così vediamo. Che
Mhm.
dici?
Sì, sì, sì.
Poi dico, io penso che comunque possiamo anche dire, magari non c'è il potenziale, cioè magari non stanno producendo abbastanza in questo preciso momento, ma magari c'è il potenziale, perché essendo comunque un'isola è molto facile, come abbiamo visto dalle mappe, che dove c'è il mare c'è molto più vento, perché non è ostacolato dalle montagne, e quindi un'isola ha molta più possibilità rispetto che a un paese intracontinentale.
Sì.
Io direi di segnarci questi punti così poi li posso segnare io
Sì,
se
sì,
vuoi.
vai.
Tu sei più brava di me in inglese perché io sono scarso, però
Anche io sono scarsa.
porca miseria.
Sono brava con yes quando chiedono se si sente.
Ok, top. Allora, intanto l'Inghilterra, UK è un'isola, quindi si possono sfruttare le offshore wind farm, ok.
Ok.
Allora, vediamo un attimo questa Irene. Tu ce l'hai presente o se vuoi posso condividere lo schermo, non so.
Se riesci a condividerlo sarebbe molto comodo, onesta.
Ok,
Però, cioè,
Carolina ci sente, vuole partecipare, non so, no. Va bene, condividiamo.
è uscito anche Tizio. Ah, ok,
Chi è uscito?
è uno
Ok,
degli altri.
allora vediamo. Qua sto avendo difficoltà a condividere perché sono un coglionazzo. Vediamo. Ok, dovrebbe condividere in questo momento, che dici?
No, non vedo. Ok, sì, scherzavo.
Top,
Sì, vedo tutto.
top.
Che poi, se poi c'è poco vento, che non si riesce neanche a soddisfare quella domanda lì, cioè che dato che la domanda è bassa, magari può essere anche quelle sul onshore, come cavolo si chiamano, che bastano. Se invece non c'è vento, potrebbe essere anche che ci sia come soluzione alternativa, diciamo, se non c'è vento, appunto, qualcosa di meno, non una renewables per dirti.
Però comunque dico, ci sono anche altre come l'hydropower, potremmo anche vedere,
Sì,
se non c'è
oppure
il
io
vento.
pensavo anche tipo steam turbine.
No, certo, certo. Allora, vediamo se riesco a... Allora, qua sto guardando la capacità delle installazioni, eh, ma forse dovrei scrivere generazione... Ok. Vediamo UK, se riesco a trovarla.
Vedi, tu sei più studiato di me anche in sta roba.
No, lascia stare. Secondo me mi stai sopravvalutando. Allora, United Kingdom, ok. Dai. Ok. Allora, se fosse corretto,
Mhm.
se riuscissi a levare. Tu stai vedendo, no?
Sì, io sto vedendo.
Non riesco a levare questo riquadro in cui mi fa vedere tutti i paesi, porca puttana. Ok, perfetto.
Ok.
Allora, se questa è la produzione di vento, wind energy
Anche
data, sì.
onshore. Anche onshore è alto alla fine.
Non è alto, a me sembra abbastanza alto. In gigawatt, secondo me è tanta roba.
Sì.
Cioè, nel 2019 è altissimo.
Sì. E nella tabella che abbiamo, in cosa è misurato? Ok.
In gigawatt.
Ok. 3. Beh, ci siamo, secondo me.
Sì. Là ti dice pure offshore wind, che infatti è il doppio del nostro. Vedi il cursore?
Esatto. Sì.
Ok.
Che poi in realtà penso che anche solo l'onshore wind basti, e appunto se magari nell'entroterra c'è poco vento, si può fare affidamento invece a quello fuori, che ce n'è di sicuro di più. Adesso non so se sto dicendo cavolate perché non è che ne capisco tanto, sincero.
No, tranquilla, siamo tutti alle prime fasi, ci sta. Io neanche capisco tanto, sto andando a cazzo. Allora, ti stavo dicendo, ok, questo però producono un po' troppo di vento, cioè quasi quasi ti direi anche un'altra ora del giorno, però il discorso che hai detto tu che potremmo dividere, quindi l'onshore wind, cercare di far sì che possa bastare per la parte interna e invece l'offshore una parte per quelle ore e poi comunque ne rimane perché penso che siano in grado di contenere questa energia prodotta.
Ok.
Volevo vedere un attimo la capacità, perché oltre che non so esattamente cosa voglio dire, la capacità delle installazioni, che però è in megawatt. Che vuol dire?
Non lo so.
Non ne ho idea.